Have you ever stopped and wondered what is actually going on inside the mind of an AI? As these systems get more and more powerful, they're also kind of paradoxically getting more mysterious. So today, we are going to crack open that AI black box and ask a really crucial question. Can we honestly trust decisions that we can't even understand?
Really think about it for a second. Imagine an AI doctor gives you a life-changing diagnosis, but when you ask why, it can't tell you. It just says, hey, trust the math. Would you? This isn't some far-off sci-fi plot. It's a very real dilemma that people are facing right now in fields from medicine to finance and beyond.
And this really gets to the core of the problem. So many of our most advanced AIs are what we call black boxes. We can feed data in one end and we get an answer out the other. But that whole process in the middle, it's completely hidden. We see the final what, but we have absolutely no clue about the how or the why behind its conclusions.
Okay, so if the black box is the problem, then a glass box has got to be the solution, right? But what does that actually mean? What are the ingredients you need to cook up a truly transparent, understandable AI? Well, researchers have laid out some key rules for what they call explainability.
It pretty much boils down to these 5 things. First up, feature attribution. The AI has to show us which pieces of data mattered the most. Next, compositional transparency. It needs to reveal how it actually combined those pieces. Then we need to see the full decision pathway, the whole journey from start to finish. Fourth, it should give us dual explanations, both the big picture strategy and the specific reason for this one decision. And finally, and this one is so important, its logic needs to have human alignment. It has to make sense to us.
So the big question is, how do we build an AI that can actually do all that?
Let's take a look at our first potential solution.
It's a brand new model called Bacon, and it's been designed from the ground up with explainability baked right in from the start. To really get what Bacon is doing, just look at this super simple decision tree for picking a job. You weigh things like salary, benefits, your personal interests. Bacon does something very, very similar, but on a massive scale. It learns from data to automatically build its own powerful logic tree. Think of it like a hyper-detailed pros and cons list for making just about any decision.
Now, what's really cool is the secret sauce behind Bacon. It's something called graded logic. See, unlike traditional computer logic that's just black and white, true or false, graded logic can work in shades of gray. It can understand that some factors are mandatory, like you need both X times Y, while other factors are more flexible, where you could have X or Y. This is way, way closer to how our own brains actually work.
And here's a little peek under the hood. Now, don't worry about all the jargon on the diagram. The main idea is a simple 2-step process. First, that permutation layer down at the bottom sorts through all the puzzle pieces of data to figure out the most important order to look at them. Then, the aggregation layer on top takes that ordered data and builds that transparent logic tree we were talking about, which leads to a final understandable decision.
This slide shows just how powerful that logic is in practice. So imagine you're trying to hire someone. A conjunction, that's the sharp peak on the left, is like saying you absolutely need a degree and experience. Both are required. A disjunction, the flat plateau on the right, is more like saying you need a degree or experience. Either one will do. The amazing part is that Bacon can learn these kinds of real-world rules directly from data, which is so much more insightful than just crunching numbers.
All right, so Bacon builds this one, big, complex logic tree. But that's not the only way to build a glassbox AI. There's a totally different approach, called the Tetzlin machine, that tackles the problem not with one big tree, but with a whole forest of simple, visible rules.
A Tetzlin machine, or TM for short, is fundamentally different from a neural network. Instead of a bunch of complex math, it learns by creating hundreds, even thousands, of really simple if-then rules. They're called clauses. For example, a rule might be as simple as, if feature A is here and feature B is missing, then it's probably class 1. The final decision is based on all these simple, human-readable rules working together.
So, how does it come up with one of these rules? Well, it's a pretty clear 5-step process. It starts with your input data, looks at each feature and its opposite, and then these tiny little agents, they're called Tetzlin automata, decide whether to include or exclude each piece from the rule. The pieces it decides to keep are just combined with an and bam, you've got yourself a simple logical clause.
Now, this is the really elegant part. Once the machine has created all of these little if-then clauses, making a decision becomes like a democratic process. Seriously, each clause gets to vote for or against a possible outcome based on the specific data it's looking at.
And the coolest thing is, we can actually watch the vote happen.
In this visualization, you can see the results for one specific input. The votes against Class 0 are all tallied up, making that negative blue bar on the left. The votes for Class 1 are tallied, making the positive bar on the right. The final decision is crystal clear, and more importantly, we can see exactly how the AI got there.
And this works for any input you give it. Feed it new data, and all those little clauses vote again. In this case, the machine is voting for Class 2 and against Class 3. This kind of visual transparency lets us see not just the final answer, but the actual strength and direction of the evidence behind it.
So what we have here are two very different approaches. Bacon's unified logic on one side and the Tetlin machine's democracy of rules on the other. But they both point toward the same, incredibly important goal, building AI systems that we can actually genuinely trust.
And this is the crucial point. Being designed for explainability from the start makes a massive difference. Let's go back to our checklist from the beginning. This table compares Bacon to some other methods. Now, things like SHAP and LIME, they can show you which factors were important, but they often don't show you the whole decision process. But look at that bottom row. Alignment with human decision-making. This is where models like Bacon really shine. They don't just spit out an answer. They give you an answer based on logic we can follow and actually agree with.
And that brings us right to the ultimate goal. As the researchers who developed Bacon put it so well, only with end-to-end explainability can we establish grounded trust between humans and machines. This isn't just some academic thought experiment. This is the absolute foundation for responsibly weaving AI into our world.
So, at the end of the day, whether we get there through the elegant, graded logic of a model like Bacon or the transparent democracy of a Tetlin machine, the objective is exactly the same. We have to move past AI that works like magic and start building systems that are willing and able to actually show us their work.
So I'll leave you with this question to chew on. As these incredibly powerful tools become your doctor, your financial advisor, maybe even your co-pilot, what is the one decision in your life that you would absolutely refuse to hand over to a black box? The answer to that question, I think, really shows why building these glass boxes is one of the most important challenges of our time.